Hello everyone, my name is Mitch Savali and this is Physics 2212 Experiment 3 Circuits. So the purpose of this lab is to observe how resistors, capacitors, and current and other aspects of circuits interact with each other in different scenarios. Some of the main models and principles used are the loop rule. So the sum of the potential will be zero in a round trip. The node rule, which is the sum of the current into a node, is the sum of the current out of the node, and Ohm's law, which is the voltage is equal to the current times the resistance energy conservation. And then some rules about capacitors and resistors in series and parallel, which you can see in the bottom right corner in that chart. A preview of this lab is that the net potential difference will always be zero in a complete loop. The system is the ammeter or the voltmeter, depending on which part of the lab we're working into. And the surroundings are the RC circuit, so it's just a different setup with different light bulbs or resistors or capacitors, and the initial conditions for most of the parts of this lab is that the circuits will always be closed with a different combination of resistors and capacitors. So the first part of this experiment was to find the current when it's connected to two batteries. There's two resistors and two ammeters, and I predicted that it would be 0.02, and I found out that the actual current was also 0.02. And when you flip the ammeter, it stayed the same, and then when you changed the ammeter to a voltmeter, the voltage was 3, which is 1.5 from each battery added together, and the current changes to 0 because the voltmeter blocks it, because the loop is not of the circuit, or the loop or the circuit is not closed. So then I use the voltmeter on the closed circuit to identify the change in potential at each of these points. And then when you add them all together, you get 0. And so that shows that the loop rule is true. The net potential and a loop will always be 0, and that works in this case. You can see on the graph in the bottom right hand corner how the potential increases through the batteries and then decreases through the resistors, and it'll end and start at 0. And the second part was figuring out the resistance of, the second part was figuring out the resistance of each of the parts of this ideal circuit. So for the 47 ohm resistor, I got 48 ohms as the resistance, and for the 100 ohm resistor, I got 102 ohms. And then for the ammeter and the wire, it's 0 ohms because it is an ideal circuit. And then the reason that the current is 0.06 is because the resistor and parallel rule, which is 1 over R, is equal to 1 over the sum of R's, which is shown here. And then another part, I connected the circuit to a capacitor and then charged it and then discharged it. So when I used the 10 ohm light bulb, it took around 8.3 seconds to charge and 6.3 seconds to discharge. And when I used the 20 ohm light bulb, it took 9 seconds to charge, so a little bit longer, and 8.5 seconds to discharge. So you can see that it takes longer to charge and discharge when the resistance is higher on the light bulb. The final part of this lab was to look at time dependency voltage across the circuit. So I charged the capacitor using a 9-volt battery, and then I removed the battery and tracked the potential difference across the capacitor. So like as the light bulb was dimming, and I tracked this, and the spreadsheet on the right, you can see, so as the time increases, the voltage decreases. And then I used the equation given of the equation, ln of V over V naught is equal to negative T over RC, and then I found that the slope of the line to be negative 0.1627, so then you calculate the RC to be 5.98, which is very close to the theoretical value, which is 30 times 0.2, which is 6, and some slight errors here could be timing or rounding. So a couple of what-if questions mostly revolve around how would the circuit change in the real world. For the first part, it would be because the ammeter does have resistance, so the RC value would be lower, and the voltage values would be lower because there's resistance. And then also for the battery question, it would charge almost immediately. It's almost instantaneous, but the prediction would not happen in real life because wires do have resistance, so the capacitor would take more time to be completely charged. And so this is lab 3 circuits. Thank you for watching.